This video covers everything we did in class today on March 3rd. We worked on lesson 7 today, but just the first half. And so this due now and the next activity are going to be fairly quick for you to get caught up. And then you'll be able to follow along with the next half of lesson 7 in class tomorrow. So the first thing that you need to do is pause this video and complete the due now. You want to pause the video and complete the due now. Okay, I'm not going to go through the do now today because in the videos for Monday and Tuesday this week, I went over exactly how to do this type of problem. So if you need some support, you can go back there. You can also open up today's notes in the main classwork folder to see the answer key to the do now and check your work. On slide 2, you'll see the main work from class today. We were focused on using hanger diagrams to talk about equations. 7.2 says, on each balanced hanger, figures with the same letter have the same weight. Your job is to match each hanger diagram to an equation. You'll complete the equation by writing X, Y, Z, or W in the empty box. So, for example, let's look at diagram A. In diagram A, we can see that we have 7 ones on the left side of the diagram. Those 7 ones are balanced out with 3 groups of W and 1 group of 1. So we know we have 3 times W, try to write that a little bit neater, which is some unknown amount, and then we have a 1. I can see that this diagram very clearly matches the final equation, because in the final equation, I have 7 on one side of the equal sign, and on the other side of the equal sign, I'm adding 3 groups of some unknown, 3 times W, plus 1. Now, that means that I can say 3 plus W is equal to 7. I know that I have 3 more diagrams and I have 3 more equations to match them. I want you to pause this video and try to match equations B, C, and D to the remaining hanger diagrams. So, you should have matched diagram B with the first equation. 2 groups of Z plus 3 is equal to 5. Diagram C is matched with the second equation. 3 groups of X plus 2 is equal to 3. And diagram D is equal to the fourth equation. I have 2 groups of Y plus 3 equals 6. Now, our second step today is to find the solution to each equation. Remember that the solution to an equation is the value of the variable that makes the equation true. So, that would be the number I can replace the variable with that will give me a true equation. In this case, I can see that 7 is equal to 3 W's and a 1. That means that 3 W's has to be equal to 6. The reason is that a 6 plus a 1 will balance with a 7. If 3 W's is equal to 6, I can use my inverse operation, 6 divided by 3, which equals 2. And so I know that W is equal to 2. And that's one strategy I can use to find the solution to an equation. A is done. I'm going to show you a second way on C, and then I'll have you do B and D on your own. In diagram C, I'm going to cross off 2 ones from the left side. If you imagine this as a physical hanger that we want to stay in balance, if I cross off ones from the left side, I also need to cross off 2 ones from the right side of the equation. When I cross off 2 ones from the right side of the equation, I end up with 3 x's being equal to 1, which I can write out like this. 3x equals 1. Then I can use inverse operations again. 1 divided by 3 is equal to 1/3, and so I know that x equals 1/3. Sometimes you'll be able to solve how we did in A, when we just kind of knew that the w's were 2. But sometimes it'll be helpful to use the crossout method to more formally see that 3x's equals 1. and C is complete. Your job when this video ends is to answer B and D. What is 1z equal to, and what is 1y equal to? When you finish B and D, you're all set for today. The only other thing you need to take care of is making sure that you finish this week's homework due tomorrow.